So hello everyone, today's LeetCode question is 3000 maximum area of longest diagonal rectangle. So it is a very easy question as we have given a 2D indexed, zero indexed integer array named as dimensions, and in which we have exactly like two elements only. So that is why we are accessing I of 0 and I of 1 only, and I of 0 will represent you the length, and the I of 1 will represent you the width of the rectangle that we wanted. Like we have to return the area of that rectangle, so we have given the length and the width. So what is the formula of like rectangle for finding area? Guess. It is L into B, or can say W, because we have given here width. So I hope you know this formula. So that is a simple thing, like you have to find out the area, but with those who has the longest diagonal. So what is the formula of diagonal? So if you have like consider, like let me consider a rectangle. So let me consider this like okay, so think it as a rectangle, and you have a diagonal from here to here. Like how I can represent that? Let's say I am trying my best to like give you the visual idea of rectangle, but you know all of these things in your like childhood. So this is our rectangle, very nice rectangle, yes, and this is our diagonal. So the formula of finding diagonal are like under root. How I would represent under, let's say sqrt under root 2 into your length. Yeah, that is for the square purpose. And if it is rectangle, then if it is rectangle, then you just have to use like that very famous thing, h square equals to p square plus b square. If you remember that, then it is to find out, like if you have a rectangle like this rectangle, and here is your width, here is your like, let's say here is your like length, here is your width, then this will, what this will be, if you have to find out this, then it will be your under root sqrt. Let's say this is length and this is your width, then this will be your formula, and that is what here we have given. So we have to find out this, and whenever we got the longest diagonal, then we have to return their area, that is your length into width. Okay, so very simple question, as you know, like you have to just traverse. Let me consider one thing, that is your uh, diagonal. A diagonal can be of your like double type, so diagonal, and it will be initialized with the 0, 0.0, let's say, and while moving through your like, let me consider in, okay, I don't have to do that, I'll just use your like this dimensions, and moving forward your length will be, what is here given, 0 is your length, so length will be your I of 0, and width, if I consider width W, then I of 1 will be your width. So that is it, and we just have to maximize like if your like let me consider answer variable as well, and so equals to, let's say, 0, and whenever you find out that diagonal is lesser than your what is that, sqrt of your L square, let's say L into L plus W into W. If it is lesser than that, then we have to update that diagonal, that my diagonal is now changed from previous one to this because it is the longest one. And whenever we are getting the longest one, we will update the answer as well, which is our area. So let me call it as area. So area will be your L into W. That is it, and just return your area. Yeah, that's the perfect answer I could like deliver here. As we have here given, if you see carefully, we have to think about whenever your diagonal is getting equals and the maximum area is there, then we have to update that area as well. So we have to consider one thing as well here, or if your diagonal is equals to this one, let me do here something like this, or rather, okay, let's be like this. If it is equal, okay, and your area is lesser than L into W, then what will do? Then also you will update the area. Yeah, and I think this will run. So let me submit this question. So that's all about this question. It is an easy one. So you have to just consider all the edge cases that we have given in the question. You have to read it like carefully, and that's all about this question. Thank you for watching this video.